Hello everyone, and welcome to this Compose workshop. In this session, we're going to do some live coding, and we're going to follow the Compose Basics code lab. So if you want to follow along, please make sure that you're using the latest version of Android Studio. So that is Arctic Fox Beta, which was released the other day. You can find the link to the code lab in the description of this session. If you've got questions around the code lab, please ask them using the Q&A system. My colleagues Manuel Vivo, Nick Butcher, Nick Rout, and Yassine Mesquid are ready to answer your questions. Okay, so what is Jetpack Compose? Jetpack Compose is our modern native UI toolkit for Android. It's intuitive, it's powerful, and it was built from scratch to accelerate development. So it will let you write UI with much less code. So in other words, it's faster and easier. So you can focus on building features and spend less time creating UI. So currently, Jetpack Compose is in beta, but fear not, stable is around the corner. It's coming in July. Okay, so let's get started going hands-on with Compose. So I am in my Android Studio and in the welcome screen. So I'm going to go to New Project. And here I'm going to select an empty Compose activity. Click Next. Let's name this Compose Basics and finish. While the app is building, let me tell you what you'll learn in this workshop. You'll learn what Compose is, how to build UIs with Compose, how to manage state in composable functions, what are the data flow principles in Compose, how to animate your composables, and finally, how to theme your composables. So during this code lab, I'm also going to use some functions from the Kotlin standard library. So I'm going to quickly add this dependency here right now, so I won't have to do this later. Okay. So let's explore a bit what was generated by the Compose template. So we have a UI theme with some color, shape, theme, okay, and a main activity. So in the main activity, we can see the onCreate function, but then also two other functions annotated with @Composable. What are these? So these are composable functions. So this is actually just a regular function that's annotated with @Composable. But this enables your function to call other composable functions within it. This function will produce a piece of UI hierarchy. So given this input, given the name input, it will display a text. And then this text function is also a composable, but this is coming from the Compose library. So with Compose, activities still remain the main entry point on Android application. So in our project, the main activity is the one that's going to be launched when the user starts the application. But instead of using the usual set content view call, we are using set content. So we're no longer specifying an XML layout, but rather using this set content method, we can call composable functions to build our UI. And then what we see here, the Compose basic theme, is how we're able to style our composable functions. But we're going to go a little bit later in theming in our workshop. Okay, how does our app look like? How do we know that? So there are two ways to run the app. So we can either, to see this, we can either run the app in an emulator, so pretty much like you normally would with any application, or you can use previews in the design surface. So to do this, I'm going to go to Split View, and this should load our previews. So previews are, to see a preview, we're now waiting for the build, and we're able to see it. And we're also able to see the application in the emulator. Cool. So what are previews? So what we've done here is we've marked a composable function with @preview annotation. So while doing this, the Android Studio allows us to see how the composable would look like. You can have multiple previews in the same file, so for different composables that are contained in that file. But then you can also add multiple at previous annotation to one composable. So for example, let's say that I want to see how my composable looks like if I have a font scale of 1.5f. And the preview renders both of them. So using a preview is great because you don't have to run the app and navigate to whatever screen you're working on. You can just see it in your IDE. I'm going to remove this for now just to have a simpler preview. Okay, so let's go to the next step. Let's actually modify our UI and build something. So first, I'm going to set a different background for the greeting. So we can do this by wrapping our text inside a surface. Moving the text inside the surface. And then I'm going to make the color of the surface yellow. So the components nested inside the surface will be drawn on top of that background color. So in the preview, we're able to see how the text is drawn on top of the yellow surface. Okay, now let's say that we want to add a padding to our greeting text. Well, to do this, we are going to use a modifier. Modifier parameters tell a UI element how to layout, display, or behave within their parent layout. Modifiers are just regular Kotlin objects, but all Compose elements, UI elements like surface or text, can accept this optional modifier parameter. So, for example, to add a padding to our text, I'm going to add a modifier, which is modifier.padding of 16 dp. dp is a measurement, the density pixels that I just imported. And now we can see how the padding was added around our text. So modifiers can be assigned to variables and they can be reused. So for example, I can define a modifier parameter to my greeting. Let's give a default value of modifier. And then here, I can use this modifier and build on top of it. So you can chain several modifiers one after the other. But what's interesting, actually, is that modifiers, the order of the modifier matters. So let's say that we also want to add a background to our text. So I'm going to use another background modifier. So let's say color dots magenta, right? Yellow and magenta should have an interesting combination. So we can see how first the padding was added and only afterwards the background was set. So if we switch the order of these two, we can see how first the background is added and only afterwards the padding is set. So the result that we're getting is very different depending on the order of the modifiers. Okay, this magenta is nice, but let's keep it simple and let's remove it. I'm also going to remove this modifier from here and also this yellow surface. Just keep this greeting a little bit simpler for now. Okay. Let's take a step back. Let's think about the applications that we're usually building. Chances are these are much more complex than just a text view just a text on the screen. So the more components you add to your UI, the more levels of nesting you create, which is normal. That's just like any other function in your code base. But the problem is that this can affect the reliability if a function becomes really large. So what we should do is make small composables that are easy to be reused. So it's easy to build a library of UI elements used in your application. So like this, every composable can be responsible for one small part of the screen and can be edited independently. So looking back at our code, we can see how the greeting is actually defined outside the main activity class. So this is actually a top-level function. So that's great because the more code we have outside an activity, the more we can share and reuse. Okay, let's refactor this code and let's make it even more reusable. So let's create a composable function that contains the compose UI logic that's specific to this activity. So I'm going to use the compose like template and let's call it my app. And then here, I'm going to move the content. And inside content, I'm just going to call my app. Okay, so this is one good step, or one first step in the right direction. So the good thing about the my app Composable is that it contains the configuration for the entire app. It has the theme, it has the surface, that's great. But now the surface only contains this grading, so this makes it very specific to this screen. But what we want is to be able to reuse as much as possible. So we want to be able to use this kind of configuration for other screens as well. So we want actually this my app composable to be a container function. So to do this, we want to pass in the content that should be displayed in that surface. So to do this, I'm going to create a content parameter, which is a function that returns unit. That is a composable function. So I'm returning unit here because, as you see also from the greeting function, we don't return UI components, but rather composables emit them. Okay, and then inside the my app function, I'm just going to call content. Okay, let's here, let's call the greeting. And then in the preview, let's also use the greeting. Okay. So in the end, what we have right now is actually equivalent to what we had before. But the code right now is just much more flexible. Making container functions is a good practice that improves the readability and encourages code reuse. Okay, let's go one step further with building our UI. Let's say that we want to show the greeting multiple times. So of course we don't want to duplicate code, right? So let's say that we want to show the greeting 2 times, one under the other, separated by a divider. So this would be our screen content. So let's create a composable function that is called my screen content. Well, because we want to show consecutive items or UI elements or ordered vertically, placed vertically, then I'm going to use a column here. I'm going to add my greeting, where I'm saying, let's say, Android. We said we want to have a divider. And then another greeting that says, there. Okay, and then here in my app, instead of calling greeting, I'm going to call my screen content, and similarly in the preview. Okay, let's see. Yeah, and now we can see how the 2 greetings were rendered one after the other. So with composable functions, well, they can be called like any other functions in Kotlin. So we can use for loops, if statements, and more. So let's try this out. Right now we hard-coded these 2 greetings, but let's pass in a names parameter to the function. So this would be a list of string. Let's say this is a list of Android, and there. And then here in our column, we can just do for name and names. And then instead of passing in the greeting, and I'm going to call this name. Okay, and that's it. We've seen how we can easily use a for inside a composable. Okay, so we've actually done quite a lot of things already. Like we've used composable functions to produce pieces of UI hierarchy. We used modifiers to tell a UI how to lay out or display or behave inside its parent layout. We created small composables that can be easily reused. And then we were able to call composables like any other functions in Kotlin. So Compose apps transform data into UI by calling composable functions. So reacting to state changes is at the very heart of Compose. If your data changes, then you recall these functions with new data, creating an updated UI. Now, Compose offers tools for observing changes in your app's data. So it will automatically recall your functions. So this process is called recompensation. Compose also looks at the data that is needed by an individual composable so that it only needs to recompose composables whose data has changed. And then it can skip composing those that are not affected. So, for example, let's say that I have a greeting of Android. So this composable, in this composable, we're hard coding the input. So Compose creates a UI tree. So, and this greeting specifically is just added to that UI tree once, and it will never change, even if the body of my screen content gets recomposed. But where does it change? Let's see an example where this changes. Let's say that we're creating a counter that keeps track of how many times the user has clicked a button. So for that, let's define a composable function that's called counter. And here we'll have a button, then on click, and we display what I've been clicked X times. Okay, so how would we do this? So we need an internal state, right? We need to have a way to hold the number of times the button was clicked. So let's see how this would look like if we have an int. So I'll define a var counter. That's 0. And then here in the button click, I'll do counter. I'll increment the counter. And then in the text, I'm going to display the value of counter. Let's run the app and see what we get. Oh, I should also add the counter to my screen content so we can see it. Okay, so we see the button, and I'm clicking on it, but nothing happens. So why is that? Like, I have a variable. Why isn't it modified? So the thing is that using an int is not enough. What we want is when the state changes for the UI to also change. And Compose gives us tools to make this automatic. So we would use a by mutable state of function that we're initializing with 0. I'm going to add the imports that Android Studio tells me to add. So as the text reads this value, it will be automatically updated every time this variable changes. But now Compose would rerun this function every time there's a change, and then we would always reinitialize our count to 0. But what we want is our variable to survive recomposition. Well, to do that, we use remember. This is actually what Android Studio also tells us to do, to use remember. And I'm going to put the mutable state in here. So by using remember, we give memory to our function. So now we can see that we can click the button multiple times and the state is updated. But the state is internal to the counter. So if we have multiple instances of the counter, then each copy will have its own state, its own version of the state. So you can see that even if I'm tapping on the first counter, nothing happens with the second one. So they're all, the state is internal. So we've just seen an example of how we can transform state, so the counter, into UI. So how data flows in your application and where you hold that data ends up being really important in Compose. Okay, so right now the counter is internal to our Composable. But what if we actually want to use the value of the count in other functions, in other UIs? So let's say that in my screen content, whenever the button count click is higher than 5, we want to display a text, something like love to count. Okay, how would we do this? Because we don't have access right now to the counts. So what we need to do is to move this internal state higher to the color of the function. And this process of moving the state to the color is called state hoisting. So how do we implement this? So we introduce as parameters to our counter composables two parameters. First, the count, that's just an int value. And this count will be used to be displayed in the text. And then we will also add an update count function. So a function that tells us when the count is updated and what is that value. So it will have an int parameter, which is the new updated count, and return unit. And then in our button click, I'm going to call update count with the count value plus 1. Okay, and then we said that we're moving the state higher to the color of counter. So I'm moving, let's call this counter state. I'm moving this counter state in my screen content. And then in counter, our count is going to be the counter state. And then in update count, we have the new count. And then we're going to assign the counter state the new count. And then we're going to use this counter state to decide whether we should display or not the text. So now, I love to count. That's right. So making state hoistable avoids duplicating state and introducing bugs. It helps reuse composables, and it just makes composables substantially easier to test. Of course, state that is not interesting to a composable color can be internal. So, for example, in a scroller, the scroller state position can be exposed, but maybe the maximum position can be something that's held internally. So the source of truth belongs to whoever creates and controls that state. Okay, so what did we do so far? We looked at how state works in Compose and how to use remember and mutable state and why it's important to hoist the state when needed. Okay, let's build some more UI. Let's update our UI. And so far what we've done is we looked at how we can place items in a vertical sequence. But in the same way, we can use row to place the items horizontally. But now let's say that we want to put this button at the bottom of the screen. And then we can let the list that we have here to expand as much as possible, but still remaining at the top. So what we want is to have some items flexible so they occupy a portion of the screen. So to do that, I'm going to wrap this for into a column. And I'm going to move this content here. And to make this content flexible, I'm going to use a modifier. And that is the weight modifier. I'm giving it 1F. So this means that this column is flexible, that it can expand. It can take as much space as it wants, but then the rest of the content is inflexible. So we also want to make sure that the column is going to fill the entire size of the screen. So I'm going to add another modifier. Let's modifier.fill max height. Let's see if we can already see this in the preview. But also run the app on the emulator and see how this looks. Yeah, we can already see in the preview that the list is at the top, and then the button is at the bottom. Okay, now let's make the names list a little bit more realistic, right? We don't want to just use a for. We've just displayed 2 items, but how do we display thousands of items? Well, before we do that, before we change that list item, let's extract the names column to a dedicated composable. So I'm just going to create another composable. Let's call it names list. And then I'm just going to move here the column displaying the content. I'm going to pass in the names, so it's a list of string, and then I'm going to pass in also the modifier. So like this, by passing in the modifier, it means that I'm allowing the caller to decide where this names list should be positioned, how it should be positioned. And then here, I'm going to call names list with names and modifier. I still want the content of this composable to be flexible, so I'm still going to use the width modifier. Okay, and now let's change the list. We don't want just 2 elements. Let's make it a list of 1,000 elements. And then every element of the list should say, hello, Android. And let's see the count as well. Let's run this on the emulator. Let's see how it looks like. Okay, so we can see our list, but now I'm trying to scroll, but I can't. But that's because column isn't scrollable by default. But to do that, to make the list, the column scroll, we can use a lazy column. So I'm going to replace this with a lazy column. So a lazy column renders only the visible items on screen, and it allows performance gains when rendering a big list. So this is equivalent to recycler view in Android views. So what do we have with lazy column? So in lazy column, we can provide the items to be displayed. So items, here is our names. And then I had to import it. But then here, what we want, we define is what should be displayed for every item. What is the corresponding UI for every item in this list? Then if we run it, should be able to scroll. Yes, we're able to scroll. Yeah, looking at this, I don't know, it's just amazing seeing that we only had to write 4 lines of code to implement something that with views, with recycler view, would have taken so much code. You know, you have to implement the recycler view, the adapter, the view holders, and so on. I know, Compose ends up being so concise and easy to use. Okay, so lazy column. doesn't recycle its children like Recycler View, but rather what it does, it emits new composables as you scroll through. And it is still performant because emitting composables is relatively cheap to constructing Android views. Okay, so we've seen how to use flexible layouts and how to display lists. Let's see how we can animate, how we can add some animation to our UI. So what should we do? Let's change the background color of a list item once we click on it. So of course we want to animate from one current value to a different value. So because we need to know once we selected an element, we would need to create a new state. We need to introduce a state that tells us whether an item is selected or not. So in the greeting, I'm going to create a new state that's called is selected. And we're going to use the same remember mutable state of that we've used before with a default value of false. So we need to know when a text is selected and when we click on a text. And to do that, we can use a clickable modifier. Because the order matters, I'm going to put the clickable modifier before the padding so I have some more space to click on. And what should happen? Whenever we're clicking on it, then it's selected. Selected should be toggled, right? Should be not as selected. Okay. So now we know when our text is selected or not. Now let's set the color. So this means that we will have a target color. And if the text is selected, then we should have, I don't know, color.red. Otherwise, we should be displaying color.transparent. So keeping the same color that we have right now. Okay, and then we want to set this as a background for the item. So we're doing what we did at the beginning of the workshop, which is set the color of the surface to be target color, and I'm going to move this here. Okay, let's see how it works so far. Okay, so now we can see how the color changes. But this is not what we want, right? We want to be able to animate this, to make this a nice transition between this transparent state to the red background we have. Well, to do this, we use animate color as state, where the target value is defined by our F. And I'm also going to use a delegate here. Without the delegate, I would have to do target color.value, and the delegate just makes it easier to use. Okay, now let's see what changes. So what animate color does is it takes a color as a parameter, it saves it, and then it generates the intermediate colors required to display an animated transition between a previous set of colors to the new one. So if I'm clicking on an item, we see that there is some animation. I think the animation is a bit too fast for our live stream. Let's slow this down. So animate color as state also allows us to define an animation spec. So the Compose offers different types of animations, from strings to repeating animations. For today, let's just use a tween because that's the simplest one that allows us to set the duration so we can see it. So for what we want, it should be enough. Okay. And we can see how it changes. I'm sorry for all the designers out there watching this. This is not the prettiest one, but look how nice it animates. And looking at the code, like this was all the code needed to write an animation. That's, That's pretty cool. Like with views, that would have taken us a little bit to write. Okay. Yeah, so what we've done here is we kind of hard-coded this color. And that's not really something that we want, right? We want to use something that's specific to the application theme. So for example, we would want to use like this kind of a purple that we have at the bottom. So this purple, or the color of the divider, all of these are colors that come from the application theme. So this is how we define the theme. So we have a composable, compose basic theme, composable that wraps the content that we want to display on the screen. So this compose basics part, actually, it's generated based on the name of your application. So it will change depending on how you named your app. But if I look inside, I can see that under the hood, this is using material theme. So that's because Compose offers an implementation of the material design system. So all components follow material styling. So we see that we have a composable material theme where we're passing in colors, typography, shapes. So the colors, typography, and shapes, these are all elements that were defined here. The colors, the shapes, and then in the type, the typography. So these are all elements that you can change so you can give that unique feel to your application. And then what we've done here is we define the color palette, both for dark and light mode. So for example, here we're setting to use purple 500. If I would change this to color.red, for example, I should be able to see how my button also changes to red. Yeah. Okay, I'll revert this back to purple just to keep it nice. Okay. So back to our application, we said that we don't want to have this as color already. We want to use an app theme. But how do we get that? So you should use elements from the material theme directly. So I'm going to go for material theme, colors, and primary. So you should do this rather than specifying the colors directly. Because like this, dark theme is automatically supported and you don't need to define colors all over your code. So let's see how this looks like. Then when we click on an item, we see how the color changes, but also the text color changes. So why is this? Well, because the material surface understands that we use our primary color from the theme, then it automatically sets the text to use on primary color, which is also defined in the theme. And then, if we switch to dark theme, we can see how the right colors are again used. So all of this is something that we got out of the box by just using the material theme from Compose. Okay, we looked at a lot of things in this code lab. We looked at what composable functions are, how we can lay out composables. We've displayed lists using lazy column. We've animated our UI using things like animate color as state. We saw how theming works. We've done a lot, and I'm hoping that this is something that's, makes me more curious to try out Compose a little bit more. So if you want to learn more about Compose, go to developer.android.com/jetpack/compose. Here you can find a lot of documentation about Compose, following a lot of topics from state, architecture, animation, theming, to accessibility and testing, including interoperability. And then check out the sample apps to see a lot of examples of how Compose works in practice. And then check out our curated pathway of collabs and videos to find out more about Compose. And actually what we've done today was this Jetpack Compose basics. that's all I had for you for today. So thank you for joining and happy composing. I can't wait to see what you build with Compose.